people that have come in to our Discord channel and through emails, as soon as someone comes in, they can just lead on something. But the key is when people come in, rather than saying, call your legislator or giving them some uniform task, we collectively take account of what does that person know how to do and what are they prepared to do, and then just do it. You know what I mean? No one's stopping you from doing it. And
this is OpenAir Weekly, where we catch up on the regular goings-on of the OpenAir Collective. I'm Adam Aston, and today I'm catching up with Chris Neidl. And we're going to just cover a little bit of good news we've had lately on some initiatives in the concrete space, which may have some of our viewers scratching their heads. How does that connect to the world of removing CO2 from the atmosphere, which is our big mission? But let me welcome you to the conversation, and thank you for getting me involved. Also, Chris.
Hey, no, my fortune to have you on the other side of this. So thanks, Adam. Really appreciate it.
My pleasure. So yeah, let's just dive in. You know, one of the amazing twists of recent time, I got involved some weeks ago after talking to you about this mission that you've commenced on. And besides the way you're doing it, which we're going to talk about in a little bit, which is sort of a kind of peer-to-peer, open, collaborative style adopted from some other technology spaces, the places you were focusing on, one is the atmosphere, but one is very much on the ground and the earth, which is cement. I thought we could start today by talking a little bit about some progress, real progress, that's happening in America, on the East Coast in particular, but that we're excited to see as a model and a set of ideas and policies could extend really practically anywhere. Maybe you could start by opening up kind of where we're at there, also laying out the land, how that relates to the other part of our big program, which is Violet, which is the removal of CO2 from the atmosphere. But kind of we need to put that CO2 someplace, and cement is turning out to be an interesting place to put it.
Yeah, definitely. So yeah, it's a little less obvious. You know, I mean, OpenAir is obviously the focus is quite clear. We want to advance direct air carbon capture for removing carbon dioxide from the atmosphere. And through R&D is where we've been, you know, some of the videos that we've published are primarily about. And that's the Violet project. There we want to make a miniature open source direct air capture machine that we hope can proliferate all around the world and build a community of people that are going to contribute to it so we can evolve the technology. Now, that's a whole history that may be familiar to people. Open source software, hardware, it's well established in the tech space using an open peer production model for those types of projects. Advocacy, while some people don't call it that, you know, activism, there are many established models actually that are very open and decentered. I mean, you could see many of the most notable ones over the last decade in electoral politics and you know, Occupy Wall Street are all quite decentralized. And so for us, we look at in our policy work, which is the other kind of big piece of OpenAir, we want to be advancing policies that help open up opportunities for direct air capture. And it doesn't seem obvious, but that actually did as our first go at this led us to concrete, you know. So I guess the first question is what does concrete really have to do with that? And so one of the cool things about concrete is we pour, it's the second most used material, you know, on the planet after water. And it is a major source of emissions, its main ingredient, cement, but it also has the capability to store carbon dioxide. It actually does that naturally over the years. It'll absorb and mineralize concrete from the atmosphere, but there's newer technologies that directly utilize carbon that either comes from industrial smokestacks, but ultimately that comes from the open air. And so for direct air capture, in order to grow direct air capture, we need to be creating markets for its use. You know, ultimately, we're going to be needing to just suck a lot of it out of the air and put it in the ground. Like that needs to be the purpose of it. But we need to make that affordable, and we need to prove out the technology. And the best way to do that is to try to find, well, are there sectors, high magnitude sectors that you can link direct air capture to, where it serves a purpose that would then cause it to scale up and the price to come down. And fuel is one of them. You can make carbon neutral fuel. There's a number of different sectors that it can attach to, but concrete is a really fascinating one for the one that I just said. So ultimately we could be taking carbon directly out of the air and mineralizing it in concrete where it would essentially stay forever. And again, we're talking about a 10 billion ton a year industry. So here we're talking about, you know, major scale. So that's how we landed on concrete. And it happened like all things with OpenAir, you know, we're just a group of people. And when this happened last year, we were a very small group of people. And we just thought, well, let's try to get a bill introduced in New York State where our members were sort of focused. And based on some of my old contacts in solar, I had conversations with a local assembly member in Brooklyn, sort of pitched him on the general idea of negative emissions. Then we interviewed on a bunch of different people in academia and in industry and environmental advocacy. And we kind of started to focus on this idea of concrete and then focusing on procurement specifically as a mechanism. The governments buy a ton of concrete, to make roads and bridges. So if we can get the government starting to buy concrete that is low carbon and uses some of these technologies that utilize carbon, you're talking about a major early adopter that could start to really kind of get things kind of going. And that's really how it sort of started a year ago. And, the process of developing that bill was itself an open process. It was just me with my Gmail account, reaching out to people, had a Google Doc going, inviting people, hey, can you take a look at this? And blah, blah. And that's where the policy came from. It was essentially crowdsourced from probably about 30 different people in very different places. And then we got the bill introduced last Climate Week, and things have really started to take off with not a single paid professional staff or a single dollar. We now have a bill introduced in both houses of the New York state legislature, and we're really close at potentially getting it introduced in a couple of other states. And then there's a whole bunch of other stuff. So I'll shut up there.
When you say there's a bill in both houses, what does that mean? What would the bill direct local entities, towns, cities, et cetera, to do, and how?
Yeah, and I'll include some stuff in the show notes, some other links that explain the policy in depth. But the idea here is that we want to reward concrete producers who are submitting bids for state projects to lower the carbon content of their concrete. And so what this does is it, one, requires the state, all state agencies, departments, authorities, institutions, when they are procuring concrete, or if it's a major developer that's building a project that's been paid for with taxpayer money, they have to comply with this as well. They have to take into consideration what the climate impact is of the concrete. And this can be measured through life cycle analyses tools that have been around for a long time, called environmental product declarations. So what we're basically doing here is that a state agency, if a concrete producer or producers submit these life cycle analysis numbers with their bids, the state then ranks them by the top performing climate performers, and the ones that have the highest score, their pricing gets discounted for review. Mm-hmm. So like the state will be looking at it, and the price obviously is a major part of how you score bids. And if you have top performance on your, from a climate impact, the price is going to get subtracted for consideration. So we call that climate competition. So you're basically directly tying the competitiveness of a bid to the climate performance of that product. And so we think that that approach of incentivizing producers, they're going to go out and find different ways to do it in ways that are accessible to them locally, that are cost effective, that they're comfortable with. And over time, as new technologies keep coming, they'll just be incentivized to keep stacking more and more of those things on top of each other to make it more and more competitive. So that's the climate competition model. And that, again, is born on a Google Doc.
On that note, it's probably worth doing just a minute of Cement 101 here to kind of explain what that stack means.
Sure.
My version, sort of journalist shorthand of it, is understanding, I think of cement as being kind of a mixture of materials drawn from the earth, cooked to infernal temperatures, in which they go through some chemical changes. And once that's happened, becomes kind of chemically active or reactive. Along that whole chain, there's a lot of opportunities to slice CO2 and carbon intensity out of it. The heat is one huge one, obviously. But at what point does CO2 actually enter the equation and sort of help sequester the CO2 and or actually improve and change the cement proper when it's being used to rebuild the an expressway in Queens or wherever we might imagine it going?
Yeah. So this is a thing that, a year and a half ago, I was just a solar guy walking into this, and I didn't know the difference between concrete and cement. I thought they were the same thing. And I've learned for just a sort of a ubiquitous, somewhat boring material, how fascinating of a thing it actually really is. So I'll include a couple of links to provide a deeper dive into, some of those sort of points. But just in short, concrete, if you take a baking metaphor, that's like the cake. That's the stuff that there's just thousands of different varieties of that have different structural characteristics that can be used for different types of things. Cement, you can say, is sort of the baking soda or the eggs. I don't know, I'm not good enough a baker to figure out which metaphor applies best, but that's the kind of magic binding ingredient that basically turns a bunch of sand or gravel, called aggregate, and water and a couple of other things into this incredibly versatile material. And so The cement is only about 15% of the volume of concrete, but it's about 80% of the
Mm-hmm.
emissions. And for the reasons you just said, in order to make cement,
Mm-hmm.
you take limestone and you heat it up to insanely high temperatures. And that requires, you can't do that with renewable electricity. You need an energy dense fuel like coal or natural gas to do
Mm-hmm.
that. So there's emissions that come with just the thermal, what you need to do for that. But then when you break down limestone, there's this process that itself, because limestone's made of, there's a lot of carbon in it, that releases a ton of carbon dioxide. For every ton of Portland cement, that's what that's called, it produces about a ton of carbon. So just
Wow.
ridiculously. And so globally, it's about 7 or 8% of total emissions. So when you're talking about decarbonizing concrete, it's not like, here's the special concrete that comes from its own special factory. It's actually about tweaking those ingredients, particularly the cement. So it can be about reducing the cement, using a different kind of cement, substituting the cement with other types of materials, not over specifying cement. So those are some of the off-the-shelf things that we can do immediately. And then on top of that, then you start to factor these really cool newer things, which are the carbon utilization stuff, right? So the big one that's on the market right now is what we call carbon curing. So that's where you take some carbon that can come from an industrial point source or from the merchant market, and you inject that into concrete while concrete is being produced. And that actually strengthens the concrete, makes it better structurally, but that also displaces the amount of cement. You need to use less cement when you use the carbon. So it has this sort of double whammy of both sequestering the carbon and then reducing your cement. And the cement reduction is actually the bigger impact. And there's a couple companies that do that right now. And then there's other companies which, there's another video which I'll post, but as I mentioned, most of concrete is just sand or gravel. And there's a possibility to start taking that material, that aggregate, and combining materials that are made out of carbon. That so you actually create a kind of a calcium carbonate or another kind of material that can then get mixed into that. So if you start to make progress in that 80% of volume that is the aggregate, and that's made out of carbon-based material, then you're talking about, really potentially a road to getting to a carbon negative material in the long term. And so a bill like this starts to incentivize, it creates a market for those types of material that doesn't necessarily exist.
I love the idea as you began to characterize it. Cement and concrete production have to be among the most inglorious, sort of humble. Almost every big regional center has to have a concrete plant there because it doesn't travel well. It's so heavy. I don't think a lot of people think of it as being a center of innovation, given how old and ubiquitous it is. And in that sense, this idea has extra appeal to me because it's kind of finding almost hidden in plain sight, potentially amazing solution to a problem. This gets actually back to the very high order mission of the OpenAir Collective, which I'd love you to just sort of remind us about, which is the idea that for a lot of encouraging progress, I think, across the spectrum of low carbon and zero carbon alternatives, solar, which you cut your teeth on, there's a need for a whole nother layer of carbon removal that we need to sort of steer into. It's not talked about a great deal, though, given all the political infighting over whether climate change, is even a factor in wildfires. The near-term conversation rarely gets to that point of, if we're going to get to 2050, let alone 2100, the challenge is to bring a lot of carbon out of the air, more than just reducing the reduction of it. Just touch on that real quick. Why is this such a critical element as part of the bigger challenge of removing CO2 out of the air? Why do we need to do that?
We need to do it because the ship has sailed. We can't solve this any longer by just mitigating, as they say, or reducing emissions. So there's the UN IPCC report that talked about, if we want to stay below 2 degrees Celsius, we already are going to have to do some removal. And we now know it's more important to stay to 1.5. And there's no scenario under which massive amounts of carbon, they estimate that by the end of this century, 20 gigatons a year of carbon are going to have to be removed. I think it's 2 gigatons a year, all of the carbon that's produced by all the vehicles on the road in the United States. So we're talking about a massive industries in reverse, pulling carbon out of the atmosphere. And you can do a lot of that. I live in Costa Rica up in a mountain in a cloud forest. Okay. I see Forests are a big part of that. Afforestation, soil management. There's a lot of biological pathways for pulling carbon out of the atmosphere. And we have to maximize those because they're ready to go. They're inherently valuable and they're proven, but even that is not going to get us beyond, a quarter of what we need to. So there's this other big gap that has to come from engineered solutions. And the thing about DACC that's always drawn me to it is that it has so many advantages. The theoretical maximum of that is like 40 gigatons a year. You can also monitor it so well. You know what I mean? You know what's coming out. It can be counted in real time. And it doesn't compete for space. When you start to do these biological solutions, you're competing against agriculture. You're competing against other land uses. Here you're talking about a drawdown density that's, an order of magnitude higher than, trees and forests. And you can put it in marginal lands. You can put it on roofs of buildings. You can integrate it into things. It can be in places that those other solutions can't. And so that's what always drew me to this. And if you're someone who has been doing this for a long time, has been focused on climate, you ultimately get to a point where it's about the math in the sky.
Yeah.
It's about what the hell do we have to do here? And so if you're truly focused on that problem narrowly, you're ultimately led to direct air capture. And that's what kind of, OpenAir started with.
I love that phrase. It's about the math in the sky. It's beautiful. It sort of gets to the intangibility of it.
And
but
it's
also
so much of the
long-term it
movements
is.
now, which are so important, and they become about battles of good and evil, and they become about so many other things that sometimes they put smoke in front of that focus that we have to kind of be on. You know what I mean?
Yeah.
And as a culture, I think direct air capture people, which I love about it, is a solar guy. In order for solar to have emerged, it had to wend its way through all kinds of ideological territory before it became the solar we know now. DACC has always been, and Klaus Lochner, the guy who invented it, is the most perfect embodiment of it. It's always been about the number in the sky. And it's not only been about that, it's also been about, we're not going to achieve the targets. We're humans. It's we're going to have to take carbon out of the atmosphere. Just accept it. There's a sobriety to it that is incredibly appealing to me. But anyway, for another conversation, I could talk about.
I'm in that school myself. I'm inspired by the idealism of all the positions on the environmental movement. But at some point, this kind of, if for no other reason that you need the additional tool, hoping we can solve it 1,000 other ways as well, but you need this to mitigate the risk of it.
And we do. We have to do everything now. That's the thing too, is that comes up a lot. This is not about doing this instead of those other things. It's about,
not an either or.
We have to do all of them now. Like that's just where we are, and no one can, who's interested in the data can convince us otherwise.
Yeah, I mean, as we're recording right now, it's mid-September, and the news is dominated by hopefully the waning catastrophe of the wildfires in the Western U.S. and a lot of political machination over, the role of climate change in them. Regardless, the quantifiable truth of that is the loss of billions of trees. And to your point, that there is a lot of hope. Even President Trump, of all people, endorsed a 1 billion tree planting model not long ago. But the idea that climate change is actually challenging the promise of tree viability, things that are planted may not survive, things that we plant in the future may not grow.
Yeah.
It underscores the reason to have this kind of additional sort of engineered solution all the more.
I'm glad you brought that up. I mean, the permanence part of that is you can't, not only the fires that happen accidentally, but you have a president in Brazil that his strategy is to burn down forests. You know what I mean?
Burn down, right.
So there's both the permanency and the measurability of it is a bit of a challenge around those solutions. But we should do them anyway because they offer all kinds of other benefits that that are inherently valuable.
Well, maybe as a last combo question before we end today's journey, one of the neat things in talking about this was the idea that this solution of kind of sequestering carbon into concrete has potential to be carbon negative. That's another, I think, brain bender, number in the sky kind of idea. People don't run into that often because we're talking more often about fractions of reduction of carbon from one fuel from how does natural gas compare to coal, how does solar compare to natural gas. Talk to us a little bit about the carbon negative potential. And from there, I think it would be great to sort of launch into the bigger potential of this, the idea that this is an open source, open collective mission, and that as much as it's taken root in New York, we'd like to see it in all 50 states and all 200 countries, as quickly as possible.
Yeah, I'll focus on that, but definitely the negative part is basically a few things that have to happen. We have to drive down emissions as much as possible from cement itself. So that's higher efficiency plants, but that takes you only so far. And a lot of that has already been done in the United States. Then we have to figure out substitutions for cement that can chip away at the content of cement. But at the cement plants as well, ultimately, we're going to have them capturing at the stack their emissions, and then either sequestering it or it's sold for utilization in other products like concrete. So all those things have to happen. Then it's utilizing carbon as much as possible. And so if we max all those out and pursue all of those avenues, not only can we reduce the amount of carbon associated with concrete, we could actually drive it below where it becomes negative. And then again, when you're talking about billions of tons of this being poured and more, COVID meltdown notwithstanding, but in the long term, there's huge growth in construction. Now you're talking about something that is not a negative, but a positive in terms of its climate impact. And that is, I think, just incredibly exciting. And then at some point, particularly as you're reducing the emissions from cement, you want to be sourcing carbon from other places, and there you could be sourcing it from the air. And that's, again, where we want DACC to ultimately be incorporated into this. But in terms of the open source part, to me, this has been the most exciting year. I've been an activist for a long time, to watch how the people that have come in to our Discord channel and through emails, and then what we've done with the state bill is that as soon as someone comes in, they can just lead on something. There's not this, like, it's been amazing how it's been this sort of all hands on deck thing. And the people who come in, it's not just like where they live and who represents them. It's who they know, what they know how to do. And through that, we've developed this highly novel policy that now other states are looking at. We know that there are representatives in the US Congress that are looking at it for federal legislation. And it came out of a bunch of people with Gmail accounts, and I think the key to it was that people will come in and then they'll leave, but or some will stay for long and their roles will get deepened. But the key is when people come in, rather than saying, call your legislator or giving them some uniform task, we collectively take account of what does that person know how to do and what are they prepared to do, and then just do it. You know what I mean? No one's stopping you from doing it. And we've seen that again and again and the way this is expanded. Now we started with the state stuff. Now we have all these local government initiatives that are really picking up steam. Local governments build a lot of sidewalks and stuff. They can be a huge market sort of driver. And universities we're talking to, and now the city of New York, and all of this happened because someone comes in the door and says, yeah, I'm willing to do that. And then they just do it. And then it just rolls from there. And that is, as a guy who spent so much time in nonprofits, I love them. And I will always, have some association with them. It's such a different thing because organizations by their nature have to spend so much energy maintaining themselves as organizations. And they hire people who have job descriptions, and there's politics that goes along with that. And there's a lot of what software people call lossiness in that. Like when you have that kind of thing, a lot can't get transferred. A lot can't get thought about. It can't get uttered. It can't get pursued. But when you have this kind of crazy, somewhat primordial ooze-like network that we have that's based on informality, you don't have those kinds of breaks, and things just accelerate and move a lot quicker. And so I think that's been a really cool thing to watch, which is happening definitely on advocacy. And certainly we're well teed up to have the exact same thing happen with our Violet project. And that's really been the theory all along, and as we grow, can we, we're not fancy. You go to our website, there's misspelling still, I'm sure. We were behind on certain things, but some of the core things that are being proven out very much are that you can do a lot with a lot of volunteers who have time in their day and they want to binge on this. That's what it is. It's not that we're hiring staff. People are binging. It's that kind of a thing. You have certain time in your day. You're going to come in and you're going to say, I'm going to spend a half an hour trying to do this thing. And I'm going to share it with the community. And then people are going to learn from that. And the cool thing is what's been happening in New York. Now we have an awesome couple of activists in New Jersey. We have people looking at it in Michigan. We have a guy in Berlin interested, and that's the way we hope will happen. We hope it'll just keep evolving and spilling out just through a bunch of people interacting online. And so far, so good.
It's amazing. I love the primordial ooze metaphor, because from that ooze will grow forth many great things. Maybe on that note, I'll throw it forward to another conversation we'll have where we've talked a lot about direct air capture in today's conversation, but wanted to focus on this application, potential application, cement. But there's a ton going on in the other part of the equation, which I think can be a topic for tons of future conversation and content you'll find on our channels. But on that note, for that guy in Berlin, friends in Michigan, and elsewhere, what do you recommend that they do and share with friends who might be interested, and to help other people learn about and get involved?
I think the best thing, what we're starting to have critical mass with, is if you come to our website and you sign up, we'll see you. It might be a couple of days, but we'll see you on our Gmail, or track me down on Twitter, OpenAir Collect, and come inside. Come into our Discord channel and just start talking to us, and join our weekly Wednesday calls once you come in. And that's the way all of this is unfolded, just through conversations with people, and that's what's kind of led to it. So I would say come to our website, sign up, or track us down on Twitter. We'll invite you inside and be part of the conversation. We'll take it from there. And you might have something in Berlin or Australia, wherever you are, that all the stuff we've been doing in New York is just organically grown. And we expect wherever our members are, new methods. And this is just concrete we're talking about. There's so many other areas already of potential intervention that we can be doing on this, that we're already thinking about, that might happen in some other place as part of the OpenAir collective. And that's what we're looking forward to. So just come on inside, I would say.
Sounds great. All right, Chris, I think that's a wrap for this week, and we'll catch up again.
Awesome. Thanks so much, Adam. Appreciate it, man.
You too.